powering a self-sustaining loop. This is how India rewrites the rules for its green future.
Every electric vehicle, wind turbine, and smartphone relies on a hidden foundation of metallic elements. Stripping the technology down reveals a severe supply chain bottleneck. The push to electrify infrastructure requires massive quantities of copper, lithium, cobalt, and rare earths, and 80% of global refining. By absorbing the high costs of processing, Beijing built a deliberate monopoly, making it cheaper to buy processed materials than refine them. That leverage is now being tested. Recently, export limitations were placed on elements like germanium for semiconductors and the permanent magnets required for electric motors. The effects hit the factory floor immediately. Indian parts manufacturers have faced halted supplies, leaving the automotive sector struggling to maintain production lines. To reach net zero emissions by 2070, India requires a secure supply of these components. Relying on imports leaves industrial sectors entirely vulnerable to sudden shortages. The government's response is the National Critical Mineral Mission. Armed with a 34,300 crore rupee allocation, the administration is attempting to build a sovereign, mine-to-market ecosystem from the ground up. The first step is mapping what lies beneath Indian soil. In February 2023, the Geological Survey of India delivered a crucial report on the Salal Haimana area of Jammu and Kashmir. This map shows the targeted geological domain, revealing an estimated 5.9 million tons of inferred lithium resources. It marked the first time lithium deposits of this scale were established domestically. To extract it, the government amended the Mines and Minerals Act. Deep-seated and strategic mineral exploration was open to private companies, allowing non-state actors to bid for exploration licenses and bring private capital into mining. Private operators are scaling up rapidly. Companies like Adani Enterprises and Hindustan Zinc's Hindmetal subsidiary are securing critical mineral blocks and deploying AI and drone-based exploration to accelerate the discovery of deposits. But extracting rock is only a partial solution. India's domestic geology simply does not contain the full spectrum of metals required to build high-performance batteries and advanced electronics. To fill the geological deficit, India has to look outward. Securing direct access to foreign mineral deposits allows the country to bypass monopolized trade routes. This is the specific mandate of Khanij Bidesh India Limited, or KABIL. It is a state-backed joint venture tasked with exploring, acquiring, and developing strategic mineral assets globally. Their operations are currently focused on South America. KABIL has secured agreements for the exploration and mining of 5 lithium brine blocks in Argentina, while concurrently evaluating copper exploration projects in Chile. In parallel, the India-Australia Critical Minerals Investment Partnership is directing funds into mature mining ecosystems. The two nations have identified 5 target projects, 2 for lithium and 3 for cobalt, to establish reliable supply chains. By tying up directly with mineral-rich nations, India secures the raw inputs needed for its industrial sector before those materials ever reach the open market. Yet, importing raw ore does not solve the core problem. Raw lithium and copper offer no economic value until they are refined and engineered into highly specialized components. To bridge this gap, the government approved a 7,280 crore rupee scheme specifically to develop domestic manufacturing for rare earth permanent magnets, aiming to cover the entire process from oxide to finished product. This runs alongside the Advanced Chemistry Cell PLI scheme. With an outlay of over 18,000 crore rupees, the initiative was designed to establish 50 gigawatt-hours of domestic battery cell manufacturing capacity by 2025. Against the target of 50 gigawatt geological scarcity, once a domestic supply chain is built, it must be protected from depletion. That requires a shift toward urban mining, extracting value from materials already in circulation. The final phase of the National Critical Mineral Mission involves establishing robust recycling mechanisms. Instead of continuously mining new rock, high-grade lithium, nickel, and cobalt can be systematically recovered from discarded consumer technology and spent battery cells. Scaling this requires international cooperation. Through alliances like the Minerals Security Partnership, India is coordinating with multiple nations to elevate processing standards and diversify clean energy supply chains globally. The strategy spans 3 continents and multiple industries. It connects domestic deep-seated mining, the targeted acquisition of foreign mineral assets, and billions in subsidies for high-tech local manufacturing. By securing the raw elements of modern technology, India is moving past importing clean energy components. It is building the sovereign capacity to manufacture its own industrial output.